Magandang araw po sa inyong lahat. Ako po si Isabela, isang mag-aaral na nasa ika-12 baitang ng Aurora Senior High School sa distrito ng Aurora. Malaking tulong po ang RBI sa aming mga estudyante dahil kahit na may kinakaharap tayong pandemya ngayon, natututo at nagkakaroon pa rin po kami ng iba't ibang kaalaman, lalo na sa food and beverage services at sa bread and pastry production. Dahil dito, mas nangasa po ang aming skills sa pag-debate at ang aming communication skills. Dahil dito, nagkaroon at tumaas po ang aming confidence sa sarili. Nais po namin magpasalamat sa SO Isabela at sa buong staff ng RBI. Sa Radyo Eskwela sa Isabela, patuloy ang edukasyon.
Senior High School On-Air Academy. Unstoppable! Delivering you quality education amidst pandemic.
To defend school opening to October 5.
Unstoppable!
Giving you accessible learning platform anytime, anywhere.
Ang klase, whatever form it is.
Comprehensible!
Buckle up and get yourself ready.
I will repeat, then you will do it later on.
Accurate!
The sphere that includes all living things.
Today, we'll be talking about rational functions.
Simplify.
This is Jaws speaking. How may I help you?
This is ZED School Radio's Senior High School On-Air
On-Air
Academy.
And now, here's your new episode for Painless Calculus.
Your guide for the subject, Basic Calculus.
Painless Calculus.
Painless Calculus.
How do you maximize or minimize something when you go to school, shopping, or church? You look at the greatest advantage and the least disadvantage when you choose. For instance, the routes you take, what to wear, what food to eat at the canteen. Logical decisions in life are made by optimizing some quantities that depend on things you can control. Good day, our dear learners! It has been more than a year of combating this global pandemic COVID-19. However, I must say that we are still blessed that our learning never stops. As what our DepEd Secretary said, education must continue even during difficult times. This is DepEd Radyo Eskwela, your school on air for basic calculus. I am your radio teacher, Ma'am Shireen Grace M. Imbag. Hello learners! I hope you are doing great today and always have the excitement to learn through this broadcast. Now, find a comfortable place, make sure that you are holding the necessary things. Maximize your concentration as we continue discovering the basicness of basic calculus. Last episode, you've learned Rule 8 in differentiation, which is derivative of an exponential function. To give you a quick recap in applying rule number 8, let's find the derivative of the function f of x is equal to 3e raised to x. Applying rules 3 and 7, which are the constant multiple rule and derivatives of trigonometric functions, respectively, f prime of x is equal to 3 times the derivative of e raised to x is equal to 3e raised to x. So, the derivative of the function is 3e raised to x. Another example, let's find g prime of x if g of x is equal to negative 4x squared e raised to x plus 5x e raised to x minus 10 e raised to x. Applying Rule 5, which is the product rule to the first two terms, and Rule 3, which is the constant multiple rule to the third term, we have g prime of x equals the quantity of the sum of negative 4x squared times e raised to x and e raised to x times negative 8x plus the quantity of the sum of 5x times e raised to x and e raised to x times 5 minus 10 times e raised to x. By performing each operation, we now have the derivative as negative 4x squared e raised to x minus 3x e raised to x minus 5e raised to x. Lots of x! I hope through these examples you were able to recall our previous topic. Last time you had your quiz, right? It's time to answer your drill. The statement was, find h prime of x if h of x is equal to e raised to x sine x minus 3e raised to x cosine x. Here, we apply the product rule to each term. H prime of x equals to the quantity of the sum of e raised to x times cosine x and sine x times e raised to x minus 3 times the quantity of the sum of e raised to x times negative sine x and cosine x times e raised to x. For the next line of solution, we have h prime of x is equal to e raised to x cosine x plus e raised to x sine x plus 3e raised to x sine x minus 3e raised to x cosine x. Then for the final line, which is now the answer, we have h prime of x is equal to e raised to x times the quantity of 4 sine x minus 2 cosine x. Did you get it? Excellent! For those who didn't get the correct answer, I advise you to go over your solution. There might be something you've missed. Right now, if you need to take your personal necessities, this is the time. We shall have our discussion of the next lesson right after these few reminders.
Tayo na sa Radyo Eskwela.
Tayo na!
Naku, ang lakas na ng hangin. Paparating na ata talaga ang bagyo. Mabuti na lang, nakita ko ang listahan ng mga dapat ihanda kanina sa Facebook ng DepEd. Ito ay ang tubig, pagkain, ID card, mahalagang dokumento, flashlight at baterya, posporo at lighter, first aid kit, kutsilyo, radyo, kumot, banig, lubid, gamit panligo, at ilang mga damit. Tawagin man kami para sa agarang paglikas, handang-handa kami.
Maging handa sa anumang sakuna. Isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.
And we're back on air. For this episode, we shall learn about optimization using calculus. The question I asked you just earlier on how to maximize or minimize something when you go to school, shopping, or church has something to do with our lesson. When taking the routes, of course, we need to minimize the travel time and traffic congestion. What about on what to wear? What do we need to maximize? We are maximizing the appearance or your personality. And what about the food to eat at the canteen? We minimize costs but maximize hunger satisfaction. We need to have that thinking on what to maximize and or minimize. In studying optimization in calculus, we need to learn first the theory behind it, which is the extreme value theorem or EVT. Theorem 8, which is EVT, says let f be a function which is continuous on a closed and bounded interval a, b. Then extreme values, which include a minimum and maximum of f, always exist, and they occur either at the endpoints or at the critical points of f. From this theorem, we have the following definitions. We say that the maximum of f occurs at x sub 0 if the value of f of x sub 0 is the largest among all other functional values on I. That is, f of x sub 0 is greater than or equal to the f of x for all x is an element of the open interval I. We say that the minimum of f occurs at x sub 0 if the value of f of x sub 0 is the least among all other functional values on I. That is, f of x sub 0 is less than or equal to f of x for all x is an element of the open interval I. We say that x sub 0 is a critical point of f if f prime of x sub 0 is equal to 0 or f prime of x sub 0 does not exist. And finally, we say that an extremum of f occurs at x sub 0 if either the maximum or the minimum occurs at x sub 0. All these definitions will only be possible if f is a function that is continuous on an open interval I containing x sub 0. To apply the following definitions, let's have this example. Find the critical points of the function f of x is equal to 3x squared minus 3x plus 4. We differentiate f and find all values of x such that f prime of x becomes 0 or undefined. Since the function is differentiable everywhere, the critical points will only occur when f prime is 0. Differentiating, we get f prime of x is equal to 6x minus 3. Therefore, we set f prime of x as 0, that is, 6x minus 3 is equal to 0. Solving for x, which is the critical point, we have x is equal to 1/2. Did you get it? Very good. Using the same function, let's find the extrema on the interval -1 to 1. We have solved the critical point of f already. However, we will only consider those critical points on the interval -1 to 1. Moreover, by the EVT, we also have to consider the endpoints. In the previous example, there's only one critical point. X is equal to 1/2. And the endpoints are x equals positive and -1. Evaluating the function at x is equal to -1, 1/2, and 1, we have the values of f of x as 10, 13/4, and 4 respectively. Clearly, the maximum of f occurs at x is equal to -1 and has the value 10, and the minimum of f occurs at x is equal to 1/2 and has a value of 13/4. Did you get it? Excellent! Let's have another example. Find the critical points of the function f of x is equal to x cubed minus 9x squared plus 15x minus 20. Afterwards, find the extrema of the function on the interval -1 to 1. First, let's find its derivative. F prime of x is equal to 3x squared minus 18x plus 15. By factoring, we have f prime of x is equal to 3 times x squared minus 6x plus 5, which is equal to 3 times x minus 5 times x minus 1. Hence, the critical points are 1 and 5. Now, let's find its extrema. The critical points of f are 1 and 5, but since we limited the domain to -1 to 1, we are only interested with x is equal to 1. To find the minimum and maximum of f, we need to evaluate the function at x is equal to -1 and x is equal to 1. Then we have f of -1 is equal to -45 and f of 1 is equal to -13. Therefore, the maximum value -13 occurs at x is equal to 1, while the minimum value of -45 occurs at x is equal to -1. Acquiring this knowledge about extremum values can help us in solving optimization problems. Many real-life situations require us to find a value that best suits our needs. If we are given several options for the value of a variable x, how do we choose the best value? Such a problem is classified as an optimization problem. We are given this problem that we need to solve. A rectangular box is made from a piece of cardboard 24 centimeters long and 9 centimeters wide by cutting out identical squares from the 4 corners and turning up the sides. Find the volume of the largest rectangular box that can be formed. First, if you need to draw the diagram, then draw it. And of course, assigning variables to all unknown quantities involved is vital. Let S be the length of the side of the squares to be cut out, and imagine the flaps being turned up to form the box. The length, width, and height of the box would then be 24 minus 2S, 9 minus 2S, and S respectively. Since volume of a box can be calculated by multiplying its length, width, and height, we have V of S is equal to the quantity of 24 minus 2S times 9 minus 2S. S is equal to 2 times the quantity of 108S minus 33S squared plus 2S cubed. We wish to maximize V of S, but note that S should be non-negative and should not be more than half the width of the cardboard. That is, S is an element of 0 and 4.5. Thus, the extreme value theorem or EVT applies. Now, V prime of S is equal to 216 minus 132S plus 12S squared is equal to 4 times the quantity of 54 minus 33S plus 3S squared equal to 4 times the quantity of 3S minus 6 times S minus 9. Hence, the only critical number of V in 0 and 4.5 is 2. That is, 3S minus 6 is equal to 0. Then solving for S, S is equal to 2. For the other value of S, that is S minus 9 is equal to 0, then S is equal to 9, which is outside the interval. We now compare the functional values at the endpoints and at the critical points. We have the values of S as 0, 2, and 4.5. Using these values of S to find V of S, we have 0, 200, and 0 respectively. Therefore, from the given values, we can say that V attains its maximum at S is equal to 2, and the maximum volume equals V of 2 is equal to 200 cubic centimeters. This is how we solve optimization problems. Having knowledge about extreme value theorem is essential. It helps us to visualize and make plans on how to solve the problem. We have learned today about extreme value theorem, which says that let f be a function which is continuous on a closed and bounded interval a and b. Then the extreme values, which include the minimum and maximum of f, always exist, and they occur either at the endpoints or at the critical points of f. Then, we also have the following definitions. We say that the maximum of f occurs at x sub 0 if the value of f of x sub 0 is the largest among all other functional values on I. That is, f of x sub 0 is greater than or equal to f of x for all x is an element of the open interval I. We say that the minimum of f occurs at x sub 0 if the value of f of x sub 0 is the least among all other functional values on I. That is, f of x sub 0 is less than or equal to f of x for all x is an element of the open interval I. We say that x sub 0 is a critical point of f if f prime of x sub 0 is equal to 0 or f prime of x sub 0 does not exist. And finally, we say that an extremum of f occurs at x sub 0 if either the maximum or the minimum occurs at x sub 0. All these definitions will only be possible if f is a function that is continuous on an open interval I containing x sub 0. That's it for today's lesson in basic calculus. Bear in mind these definitions, for they are vital in solving optimization problems which can be used for future endeavors. If you need to take some personal necessities, again, I'm giving you this moment. Right after this short break, you shall have your drills.
Tayo na sa Radyo Eskwela.
Tayo na!
Taho kayo dyan! Di makatulog sa gabi sa kaiisip, damdamin ko'y mayroong lungkot hanggang sa panaginip. Oh, Berto, di ka ba nakatulog kagabi? Hindi nga ho, Kuya Pekto. Dala ho siguro ng lungkot ng pag-iisa dito sa bahay. Di ho kasi makalabas dahil sa COVID-19. Hay. Berto, may 3 bagay na dapat kang tandaan para maiwasan ng lungkot sa mga ganitong sitwasyon. Una, alamin ang dahilan ng iyong kalungkutan. Pangalawa, maaaring ipabatid ang iyong nararanasan sa mga taong malalapit sa iyo. Nariyan ang internet para makausap mo sila. At ang pangatlo, ilaan mo ang iyong oras sa mga bagay na ikaw ay magiging abala. Hindi lang pisikal na kalusugan ang mahalaga, Perto, pati pang kaisipan rin. Tatandaan ko yan, Kuya Pekto. Maraming salamat sa payo. Isang paalala mula sa kagawaran ng edukasyon at ng himpilang ito.
For this episode's drill, you need to solve this problem. A gardener wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other 3 sides. Express the area in terms of x and find the value of x that gives the greatest area. Again, for this episode's drill, you need to solve this problem. A gardener wants to make a rectangular enclosure using a wall as one side and 120 meters of fencing for the other 3 sides. Express the area in terms of x and find the value of x that gives the greatest area. That's your drill for today. Answers will be revealed on the next episode. You may continue answering it even when this broadcast ends. We are done with another optimal episode. If you still have questions and clarifications, you are free to contact your teacher via text, email, or Facebook Messenger. Please don't forget to submit your learning activity sheets on the scheduled time at the drop box intended in your area. On behalf of our scriptwriter, Mr. Kisherwinville Correa of Cabatuan National High School and the SDO Isabela RBI production team, I am your radio teacher, Ma'am Sherin Grace M. Imbag of San Miguel Integrated School, Ramon District, saying, stay positive, test negative.
Pagkatuto ay walang naiiwaan, kaya halina sa Radyo Eskwela.
Patuloy ang edukasyon para sa ating henerasyon.
Sa daan ng pagkatuto ay walang may iwan.
Kaya halina sa Radyo Eskwela.